So, good afternoon, ladies and gentlemen, those who have joined in from various parts of the world, and good morning to few of our audience who are joining in from Europe or maybe US. Uh, it's a great honor and a privilege to be moderating this session with Professor Ghosh, Professor King, and Peter to come in to discuss on a very relevant topic, which is shifting gears in electric vehicles ecosystem. When this whole panel discussion was created, we felt that this itself is a challenge, and what is also a bigger challenge is to follow it after what we heard from our previous speaker on Hyperloop. This really tests the reality of EV ecosystem because we have some ground to cover if we have to really compete with Hyperloop. Our focus, of course, is going to be how do we shift gears to EV ecosystem. And of course, we have been hearing since yesterday that there are 4 or 5 challenges which are there. It would be on regulation, preferences about from customers, technology readiness, and of course, ecosystem readiness. So we have curated this panel discussion with three of you, and the idea is to listen to you all from your experience and what you have seen of this whole work on EV ecosystem, and how do we take this forward. We want to see how India is made more ready to handle EVs. The structure what we can follow for this discussion is I will request three of you to speak for 5 minutes each. I'll pose a question, what is there on my mind, which I would like you to focus on. And then we will go through this in a conversational style to understand more about the areas which you have touched upon in your opening address. We will also have Q&A from the audience. So to the audience, please keep filling in the chat box with your queries, and we will surely try to answer and get the answer for most of them as we can. If it's okay, I will start with Professor Ghosh. Professor Ghosh,
Sure.
you represent the academia for us. And in order to get us going, let's say in India, for the EV ecosystem, what do we need to focus on from your experience? Is it batteries? Is it the materials which go in making an EV? Are you more concerned with the regulation and the policies which the government is going on? Or the ecosystem itself, like the chargers or many other things are not ready? So what's going to be your perspective on how can we shift our gears to get on with the EV ecosystem? Maybe take
Yeah,
about
thank
five minutes
you.
to say so. Yeah.
Yeah, thank you. And I hope I'm audible to everybody, right? Yeah, okay. So nice that you have mentioned all the 4 points, but what is the common thread to answer comfortably for the 4 points is how much confident we are from design board to the road or to the air in terms of technology, in terms of its safety, in terms of its reliability, and in terms of its affordability. Right. So yes, already we have vehicles where we are using a fuel-based energy system. And now the question: the moment we want to shift to electrical, first challenge will come. We need to ensure that the points which we have achieved through other source of energy, we should be able to at least get 60 to 70% of those points achieved. Right? We cannot. No, the customer will not accept if we are not meeting those requirements because we are already conditioned to that, and all our logistics, all our expectations are based on how fast we can go, how safely you can go, how reliably you can go, and how good is the crisis management. That's extremely important for public domain. Now, when I started, I'm not an electrical person, I'm an aerospace person, and when I was working with an aerial vehicle, air taxi we started. The first challenge which my student asked me was, do we have infrastructure to even test those subsystems required for an aerial vehicle with energy, not conventional energy, it may be battery. And you will find that most of the challenges in battery chemistry was to how do I get the required energy density. How do I get the power density? How do I get a safe energy dissipation? That's also extremely important. And then we realized when I started working, we realized that we do not have the infrastructure even to test an electrical vehicle in terms of its energy evaluation, in terms of performance, in terms of safety, in terms of reliability. So that is one of the test platforms. The lack of test platforms, or in a positive note, I will say creation of reliable test platform will be extremely important when you are trying to shift the energy source. Despite we may have plus minus advantages, pros and cons, that's different. The whole issue is that are we really sure we have correctly gauged today's success of whatever we have in terms of reliability, in terms of performance, in terms of cost, in terms of crisis management. So one of the compromise which I have seen and which has worked is why don't you initially go for a hybrid class, right? So we are actually taking advantage of something which is already available and something new we are pumping in, right? And that gives us a confidence, that gives us a time to improve and create confidence among the stakeholders. If you see, I just give you example what we learned from COVID-19. The whole problem was we didn't have infrastructure even to test whether somebody getting infected or not. That testing has made so much of difference and so much of confidence it has given to the common public that yes, once testing is done, the rest things can be handled to the best possible way. So in electrical system or energy, if you are going, you will find a lot of conflicts coming up, which is natural because after all, world is driven by investment, world is driven by returns. Overnight, you cannot create a threat. How good, bad your technology is on the existing technologies, right? Because it means a lot for that is one of the silent part of an ecosystem. Are you creating a disruption? The entry of new source of energy, maybe electric energy through battery, should be carefully inducted without really creating spike of disruption. If you create a spike of disruption, the sociology says there will be a lot of resistance, right? I have seen when there's a discussion going on changing even the electric in the fuel-based train to electric trains, right? There was a lot of lobbying going on because I understand why it happens, right? Because a lot of investment has gone. But then how to overcome that? We can overcome that if we can really show that this addition of this is going to give you or give us something which is much at a higher scale so we can handle it. You remember those mobile network system from analog to digital, right? This transition was not easy. Even if you go back to history, that fps system to mks system, right? It was not, it was very easy on a drawing board to talk about MKS or SI units, but all the infrastructure, mostly or developed countries, they use FPS systems. So now their tools, jig, fixture, all those cannot be disturbed. So how do I handle it? And through my own experience, the greatest challenge of electric vehicle, if you are talking in terms of battery, and parallelly somebody is working on fuel cells, there are many things will go on. The best part would be to look for some sort of a hybrid system so that you give a lot of cushion to the electric or the battery chemist to find out a better energy density. Today you operate around 278 or maybe 300. In the Amicel I visited, where 300 plus they're operating. So we need to focus there and we need to see that the ecosystem in terms of safety, in terms of testing and create a confidence in that. Once we do that, then the policy makers or the regulation becomes simpler. Today, what happens? We always say the regulators are creating a problem. So regulators are not anybody outside us. If we give confidence to the regulators that yes, this is reliable to this and these are the failure index for a subsystem, The regulators will also only talk in terms of the objective data points they have. So the focus should be on creating a first focus should be you really do the good chemistry and get a good battery solution or a fuel cell solution, whatever it is, and make it reliable, make it predictable, and make it in such a way that the crisis management becomes simpler. The crisis management should not be something which will override all your expenditures, right?
Right.
Like a battery, common sense, it is something like you are sitting on a bomb, right? High energy density is there. So that is what my learning from my students and whatever projects we are doing, the amount of UAVs we have lost because we were not ready in test wise. How do I handle 1000 ampere current for a short duration? How do I
Sure.
handle the capacitor bank? So that is where what initially I will talk about it, right?
Right.
That's my
Thank
as,
you.
as
Thank you, Professor Ghosh. Uh, Professor King, great pleasure to see you once again. We have met in the past in the driving steel, and of course to the audience, those who don't know about Professor King, he wears many hats, as we heard from N. Rajesh in his introduction. So I'm going to request you, Professor King, to wear your hat of a practitioner. You have seen what any government or any society or any market can do to implement EV ecosystem. Uh, what we heard from Professor Ghosh was areas which are important. There's almost a suggestion that we should prioritize in a certain way. I want to draw on your experience for the benefit of the audience that if we have to get this speeded up, what would be your priority? What is your timing to introduce certain things to get EV ecosystem to be shifting gears?
Okay, thank you, Peeyush, and very nice to see you again after a few years. So, yeah, thank you for your introduction, and good afternoon to everybody. I think this question of acceleration is really an excellent one, and it was what I was preparing to talk about. We have coming up in November COP26, which will be held in the UK this year in Glasgow, a conference of the parties. 195 countries signed up to the Paris Agreement in 2015 at COP21. And that was all about keeping global warming under control and getting to grips with it, reducing and eliminating the effects of that. And one of the particular challenges for that is of course decarbonizing our industry, our lives, and so this question of electrification and the push to electrification is a key part of that. Since 2015, we've had challenges along the way. USA pulled out of the Paris Climate Agreement. Hopefully they will come back in again. And we've had the COVID-19 pandemic, and Professor Ghosh has talked about some learning that we can take from that and apply that into the field of electrification. But we have to continue to focus on how we can reduce and eliminate the effects of climate change while we can, and that is the acceleration that we need to make. Some people have suggested that the technology will come to our rescue. That's not really good enough. We have to work collectively, collaboratively, and probably globally to actually drive that and make that happen. It will not happen by accident. There will be some breakthrough by serendipity, but fundamentally we've got to really put our brains together. Again, learning from the COVID pandemic, there was a global collaborative effort on developing vaccine, and I think that is something that all of the countries who participated in that can feel proud of. But we have the climate crisis that we also need to treat in the same way. So that's why I'm pleased to be here today at Materiality on the discussion panel. I'll just talk a little bit about where I am now. I've been 4 years with WMG at the University of Warwick, working in the high-value manufacturing catapult team. Our founder, Lord Bhattacharya, enjoyed a close relationship with the Tatas over many years until he passed away 2 years ago. But we have a tremendous legacy to build on, and we've accelerated our own work on low and zero carbon mobility since that time. Just recently, we've appointed a director of micro-mobility, which is a real fast emerging segment of the overall drive to the electrification of transport. So at WMG, yeah, we've been around for 40 years, founded by Lord Bhattacharya. We're a department within the University of Warwick, but we have a mix of academics and engineers so that we can take the academic excellence and start to work with industrial partners to deploy that and make some of that academic research a manufacturing reality. We've got a lot of partners on site from Jaguar Land Rover and Tata Motors European Technical Centre, about 350 engineers and researchers from them. And we work very closely with those Tata Motors organisations. We also obviously have a significant education platform, and I think the skills requirement is one of the key challenges for us. We have a lot of invested capability in mechanical engineering, some in electrical engineering, and we really have to move into having a significant and growing capability on electronics engineering. We're working at the boundaries of the capability of the power electronics that we need to develop and make in volume in order to deliver the kind of control systems to control the energy density and power density requirements that will come from the energy storage systems, be they battery or hydrogen, for example. My colleagues in our power electronics team, they say they spend a lot of their time building new control modules, starting to test them, and then watch them go up in smoke and flames, because the thermal management challenge here is very significant. So there's a whole bunch of technology challenges that we need to get to grips with, and we have research groups at WMG and across the UK that are looking into those technology challenges. Which brings me to what I've been working on for the last 2 years, which is the Driving the Electric Revolution Challenge. It's a UK government-funded research and development program, but aimed at building manufacturing capability in power electronics, machines and drives. So everything you need to harness the energy from batteries and deliver that into our transport systems. And it's a broad challenge which gets us into the ecosystem situation. In the UK, all car sales have got to be zero carbon by 2035. No 100% internal combustion engine sales from 2030. So it must be at least all hybrid. New aircraft will need to be electric or hybrid to meet next phase emissions and noise legislation by 2040. Renewables, energy production, we need to increase that in the UK. We've got sometimes to around 50% of our grid load in renewables, but we need to get closer to 80% by 2050 in order to meet our climate change commitments. High-speed rail. We've talked about the Hyperloop in the earlier presentation. We'll need to continue with rail networks and high-speed rail networks. We will have no new diesel trains in the UK after 2040. We need to reduce CO2 in marine transport, and that's a global challenge, by at least 50% by 2050. And the whole field of power electronics and electric machines is critical across that whole spectrum of required technology challenges. So it's a key part, and that's why I'm really pleased to be part of the Driving the Electric Revolution program. So I think that kind of sets the scene, and it's this acceleration which is so important. We would get there in time, but we need to get there fast.
Sure. Thank you. Thank you, Professor King and Professor Ghosh, for those opening comments. And what we heard was surely about some timelines which are important for us to keep in mind. We heard some important concepts like hybrid, collaborative effort globally and through startups, what we heard in earlier in the day. I'm going to invite Peter, you to come in and look at this whole thing from two pieces of puzzle. One piece is like a steel company. Are we ready in terms of the materials which are going to supply for the EVs so that they can shift gears? And second, you also have worked in an auto company. And from an engineering point of view, as an automotive engineer, do you think this is a formidable challenge to get going with 2025 and 2030? How ready are automotive companies? Because we keep hearing it's a catch-ball effort which is going on. So we are lucky that we have somebody like you who has seen both sides of the table in some sense of the term. You have been an automotive company player, and you have now started to work with a steel company. So give us these perspectives, in just 5 or 6 minutes, please.
Okay. Good afternoon, all, and thank you for the invite to be on this panel this afternoon. From a automakers or the body in white designers perspective, it's some exciting times because they've got some new technical challenges that they've got to overcome to make the body in white as light as possible, while the overall curb weight of the vehicle is increasing because the mass of the battery pack is some 300 to 500 kilograms depending on the size of the car, which puts some more design challenges on the body in white people to manage the crash energy around the battery cells, while the crash energy has gone up because of the weight the vehicle has increased. That's for frontal impact. For side impact, where you need to protect the batteries, because the legislation says that you're not allowed to leak any fluids from the batteries. The batteries are also very expensive, so you don't need to damage them during a crash. And you're also not allowed to have any electrical failure within the battery system. But if from a side impact point of view, you've got a very short distance that you have to manage the energy from that crash. You need a slight crumple zone, but then you need a solid backup structure so you don't impact and get any damage to the battery pack. From a steel point of view, there are lots of third generation steels around today that are helping the body in white designers doing that. So steels that are maybe up to 1500 megapascals in terms of strength levels. The trick for a steel company is to try and get it to be very formable but very, very strong, and those two targets conflict with one another. So you need to choose your material in the right place in the body and weight structure. So right material in the right place. You also find that a lot of automakers are thinking about other materials besides steel for their vehicle structures. Some are using aluminium, some are using carbon fibers. They've all got different specifications, so they're all different weights, different costs, and the OEM has to pick the right material for its application. From a CO2 point of view, or an emissions point of view, sorry, CO2 point of view, there is we do produce carbon into the atmosphere as we make steel. As steel makers, we have large R&D departments who are looking to reduce the amount of CO2 that we do put into the atmosphere. But as you probably appreciate, in the world, the raw materials are found in different places. So you'll get iron ore in one place and coal in another. We still have to bring those together by marine transport. So there is a small amount of carbon given away just getting the raw materials to plant. And then within plant, we are all working to reduce our CO2 footprint. There's a lot of steel that can be recycled, which is good for the environment. The electric arc furnaces, you can recycle 100% of the steel that you put into there, which is really good. But we still need to think about the CO2 that's used or produced when making electricity as well, generating the electricity. So the whole automotive business needs to look at where all of the emissions are coming from. The CO2 emissions are part of the manufacturing chain, whether it's from raw materials, steel, and then you get the vehicle on the road, which doesn't actually, if it's fully electric, doesn't actually produce any emissions. So we've got no tailpipe emissions anymore. But we need to still look at the whole chain from raw materials to use on the road. Some automakers are also thinking about having the platform as that you change, so you can have a different top on, a different upper structure on the vehicle, and then when you need a change of vehicle, say the vehicle's 10 years old, you can maybe change the top but keep the platform with all its drive gear underneath it and battery packs underneath it. So recycling large chunks, large assemblies of the vehicle, and that way you're reducing the carbon footprint in the vehicle.
Sure. So Peter, it brings me to one follow-up question for you. And this we have always wondered, as a materials company, we tend to believe that materials is an ultimate thing to be solved. But I want to request you to share, to an automotive company, how often do they think about material challenge in this whole Evo ecosystem? I think so. I would believe that materials is an important part, but there are many other challenges for them to deal with. So does material come in right there, right at the top, or we are just there whenever we require it? Materials companies will come forward and supply us the material what we want. So in some sense, it's not a co-creation. It is about asking from a supplier to supply whatever we want. So what's the mindset which is there when it comes to EV ecosystem creation, or EVs to be created by an auto company?
It's a little bit of push and a little bit of pull. So push from the steel company because they've developed new materials, and it's some pull from the automakers who want to use new materials that are stronger and lighter, but the automakers are also risk averse. They, for every vehicle they don't sell because there's a problem, it's lost revenue. So they need to be 100% confident that any new material they deploy on their vehicles will work for them. So there's a lot of research that goes on from the steel companies and then with the OEMs, making sure that everybody's happy with the material before it's used in anger on a production vehicle in high volumes. And all of the problems with using new materials need to be ironed out before the vehicle goes live, because if they have a problem in production, they will then start to lose money because they can't sell the vehicle or make as many vehicles as they like. So the automakers are risk averse, so it's a little bit of push and a little bit of pull from both sides.
All right. So then in that case, as an automotive engineer, as a steel company, we still have an opportunity when it comes to EV to co-create when it comes to creating an EV. Professor King, I want to come back to you, and then we will come into here from Dr. Ghosh. But one of the questions which one of our audience has asked is, from your experience and your understanding of this whole subject, do you see any difference in between China, India, and Europe? So China is by far the largest market today. Europe is there in terms of the number of vehicles, and India is just about in the nascent stage. And that's where we want to see. We don't want to take 35 years, to reach there. We want to do this in half the time or even shorter. We want to see EVs to be coming in, because if affordability is an important thing, if if we believe that personal mobility is an important aspect which society wants, why would we not get on with the EV thing? So, is there anything which India can do, which others learned while they were implementing, and we can, let's say, fast forward it? Your thoughts, Professor King?
Yeah, that's it's a very interesting challenge, and I think the development of national programs and capabilities is it's always moving at a different pace, and countries are starting from a different position. If you take China, although they have significant investment in coal-fired power stations to fund their to support the energy requirements of their industrial growth, they're beginning to recognise that they need to shift away from fossil fuels as part of their energy generation. Their internal combustion engine infrastructure, considering the size of the market, is probably less well developed than in Europe and North America. And so I think China have a great opportunity to almost leapfrog the established, if you like, old technology embeddedness that there is in Europe and in North America. Plus, of course, they have greater access to the rare earth metals that we will all need in increasing quantities in order to deliver on the electrification challenge. So, for example, in Europe, we must now develop a focus on recycling and reuse, and really pushing circular economy needs in order to really make the best use of the scarce resources that we have in terms of raw materials, and start making better use of existing materials as the products they're in come to the end of their useful life. And I think India kind of sits maybe somewhere in the middle, where you've got a huge population, big requirements for personal mobility, but already a big emphasis at the micro mobility end of the personal mobility spectrum. And it may be that that India's got an opportunity to really move perhaps away from regular medium-sized passenger vehicles more towards the micro-mobility options and use the decarbonisation thrust to really push ahead with really small, lightweight, efficient personal mobility solutions. And the other real challenge is we have to decarbonize our cities, and that is a particular challenge for all countries, but perhaps particularly in India, where you've got some a large number of large cities that have got high levels of CO2 emissions right now. And there needs to be a focus from government on the decarbonisation of cities and everything, and that is a real ecosystem challenge that that transport has a part to play, but only one part. It's the infrastructure and the energy production which needs to be part of that, and I'm sure that's something that Professor Ghosh will want to talk about.
Yes, yes. No, so we heard some two very useful things, and so first is you're saying that we don't have to copy exactly what has happened in Europe and China. We have to find our own solution, which may be focused on micro mobility. We have to be very conscious of the state of carbon emissions which are there in the cities where we will have these vehicles going in, and so therefore governments have to step in.
Yeah, I think so.
In a way, there is no direct one point solution. There is a multi-pronged approach, but it has to be customized for India as we shift our gears. Yes, Professor King.
Yeah, I think that's absolutely right. Each country will need to set its targets, and I briefly ran through the kind of targets that the UK is setting for the whole energy ecosystem. But then you need to develop the roadmaps that you will need to get there, so that the targets actually then become a plan, and that's the real challenge for government. It's lovely to have a target and keep talking about it as a politician. You have to have a plan to back that up, and that's a big challenge for every country.
So it's what we have heard so far, of course, from the governments and everybody is a North Star target 2030, 2040, 2050. But future does not come, as Professor Vijay Raghavan says, does not come on one day. It comes every day, bit by bit. So you just need to have so-called an annual or a biannual target to achieve certain things. Professor Ghosh, I want to come back to you to touch upon one thing which you mentioned right at the start about hybrid versus electric, and your suggestion was that as a country we should go for a hybrid model or hybrid solution. Are you saying this because you feel that we are not ready from the infrastructure point of view, and we will cause anxiety in consumers? Where will they get the vehicles charged? Or you feel that it is a better solution from technical point of view, from the readiness of the car companies to be able to find from gasoline to an hybrid and then to the EV, and so that's the gradient which you are recommending?
Yeah, this, if you see the acceptance towards electric ground vehicle, right? It started from rickshawalas, right? Then auto rickshaw. Okay. But once it got accepted, then the regulators had to modify the regulation because their dynamics are different, right? And then suddenly policymaker try to look for charging station to create a right type of ecosystem. So what I have seen, there is an acceptance. Now when you come to air vehicle, when you leave the ground and go, say, VTOL, like vertically take off, landing from one point and then landing at another point, the the crux of the matter would be to create confidence is if you can invest in urban aerial mobility. That is what a crowded city looks for. If you can, say, 100-kilometer range, right, or say some sort of air ambulance if you want to go from South Delhi in India to even the southern hospital, the jam, the road traffic jam creates a huge problem. And if you see internationally, the type of work that is going on, and we are very close. Another 3, 4 years, you will find if you are targeting judiciously that yes, I target 100 kilometers, and that will be all electric, okay, and that satisfies our moderate green policy with a clear-cut understanding that is battery a green solution 100%. Whether the battery recycling is possible or not, this question somebody has to address. Now, when I say hybrid, when I try to extend the range, right? So that is where I talk about hybrid because if you do short urban aerial mobility, you have got huge data about the performance, the problems, the technology, challenges, and you learn from there. Then you extend. So that time you give when you are doing the hybrid part, and that causes reduces the concern about safety because some data is already there. Good, bad, and ugly of a fuel-based system. So that is why my approach would be, first urban aerial mobility, 100-kilometer range, you go full electric for aerial vehicles, which will come definitely within 3 years, 4 years time to come. And regulators also will be comfortable. The way the regulations, as I told you, as you give confidence through technology, regulators are also comfortable. Right? The only problem, if we don't give confidence through technology, regulators will be paranoid. And naturally, they have a bigger role for safety. So that's why I always say you go for a short urban aerial mobility electrical, and then you go for alternator generator or hybrid, maybe parallel hybrid, series hybrid, and gradually you move, and that addresses the main concern of green, right, and the pollution level. Overnight, if you want to do something, we are not ready for it, and that is not the way of evolution. If you want to create a product which is safe, which is reliable, you have to give time, you have to invest, you have to be. So that is why I say I put in two phases, right? Okay.
Yeah. No, this is useful. And I have a follow-up question. But before I come there, I want to ask you, Peter, one more thing.
Mm-hmm.
In your experience of seeing a steel company or a materials company working on EVs versus passenger vehicles or IC engines, lightweighting is the order of the day, whether you are making a gasoline engine or an EV. From a materials point of view, what is the different stance do we have to take so that we can get more materials out there? Because what for want of materials, we don't want the EV journey to take a back seat or take a slow speed. So what would be your recommendation from materials point of view, what we should be doing? Is it about joining of materials? Is it about only doing lightweighting to high tensiles or something else which comes to your mind?
Okay, interesting question. Lightweighting is very important for internal combustion engine, and it becomes even more important for electric vehicles because the weight of the vehicle will determine what the vehicle range is from a fully charged vehicle. But what OEMs are now looking at, instead of lightweighting, they're using the term right placing, so placing the right materials in the right areas of the vehicle. It may be that instead of having steel or aluminium vehicles that we have today, there'll be more mixed, which will give some technical issues joining steel and aluminium together, but it can be done. There are some examples on cars that have been in production. I don't think they're still in production, but you can join steel and aluminium together, just the same as you can use composites as well on vehicles. It's about finding the right balance for you as a company that you're happy with the cost and you're happy with the performance and you're also happy with the weight. Obviously, everybody would love a really super lightweight vehicle structure, but that does come at a tremendously high cost, and it wouldn't then be affordable for the people in the street to buy it. So you need to get the balance to what's affordable, what is the right weight for you, and for your customers.
Sure. Yeah. So now, Professor Ghosh had also touched upon technology solution which is both affordable and feasible. And sure enough, it's also valid in the case of materials. Professor Ghosh, want to come back to you, and you were touching upon that area of urban area mobility, and also what we should be doing in the journey for the EVs. Uh, in your experience of dealing with the government, and you know that there is Niti Aayog, which is for audience who are not from India. This is an equivalent of a planning commission, and they are the ones who frame policies and regulations which are going to be implemented in India. In your interactions with government or otherwise with giving them inputs on what we should be doing and what should be the readiness of it, we only know of certain initial rules which are there and those North Star announcements which are there 2030, 2040. In your opinion, in your discussions, what are some things which they are contemplating in order to promote EVs to be adopted?
See, I can restrict myself to aerial vehicle, right? With that part, I have constant interaction, and I'm also part of those, US rules committee and all. That's why I was very gentlemanly pointing out, unless your technology, our technology is visible in terms of reliability and safety, right? Any policymaker will not draw confidence. But let me tell you, last 1 year, there's a huge shift, and you will find so many things, so many options are coming up now, and so many exceptions are given, right? So, and then also you see one very important thing has happened, that there is a quality control unit has been created, okay, where now you can go and test and get yourself benchmarked. That's why I was telling you, if we want to really move fast, you need to have very good infrastructure where you can test your subsystem and get some sort of a confidence that yes, this battery, this motor, and this other reliability index we have, and we are almost close to that because this is happening globally, not only at one point, no, on India. If things are available, but everybody wants to promote it. And the easiest solution to make a good step will be that urban aerial mobility, because there is a demand, there is a technology available. It's a question of integrating them and build a confidence. The moment you build the confidence through technology, through testing and all, regulators will open up. So that is what, see, if you are giving permission for helicopters, you are giving permission for, you remember unmanned aerial vehicle, even beyond visual line of sight. Even today there's a difficulty, but if you see carefully, these things have been relaxed. Why? Because now you can test your motors. There's a data. Okay, how many, what is the reliability of those motors, and what is the fail-safe inbuilt in the design, right? If you are flying with the four motors, there is no redundancy. Naturally, regulators will not permit you, right? Okay, at this stage. So those things are implicitly coming because the policymakers also want this, and the technology people also want this. So that is converging. So I am very positive about it, but the condition is very simple. We have to make our technology not claim oriented, but it's visible. It should be visible. The data should be available, right? If we do that, and any sensible organization will do that, and that is the only way to move forward. There is
Great.
nothing like branding. You have to show the data.
So testing and of course technology which is visible, leading to confidence of people as well as regulators, and then
Yeah.
of course the adoption will come in, and that's when we will come and hit the tipping point, which is what people are always wondering, that will the tipping point be 2030 or 2040? In your opinion and in your recommendation, what we are hearing is we just have to do our bit of work, whether in academia or for that matter in industry or in automotive, and then give confidence that this can be done and adopted.
Yes. Yes. It's almost like vaccination. If you see the example of vaccination, unless things are becoming, the data is coming up that it is safe, even doctors were not taking those vaccines. It's as simple as that, right? So you have to be open, transparent, right? Okay, this many tests has been done. These are the failure rates. All three have to become transparent. It's not question of. I always say the lead should be by the industrialists and the visionaries. Not lead should not be by the businessman. I am giving a loaded statement. If you look this as a businessman first, you will not succeed. If you look as an industrialist first, businessman will succeed. So this paradigm shift you have to make when you are trying to shift from one technology to another technology for societal needs. I hope
Absolutely,
I'm not too
absolutely.
loaded.
No, this is really any point in time in the history also. Whenever we have leapfrog to adopt any different technology, we have done something new. It was a call of an entrepreneur. It was a call of an industrialist rather than a business that I will give a bigger car or a better running car. It is now a different concept altogether. We are coming to nearly the end of the discussion. Time just flies. We have been able to take a few questions, from our audience as well. Uh, what I'm, let's say, going to do now in next 2 or 3 minutes is to attempt a summarization of it. It will also capture in some of the discussion since which we heard since morning. Uh, I hope I'm able to do a good job of it, but I'm of course happy to hear Professor King to say some last words after I have attempted to do the summarization. So what we have heard is it's not about a chicken and an egg problem. What we saw from Tata Motors is they can create an EV and sell and to make it to a largest selling EV in the country. And we can always, of course, argue whether the EV infrastructure is ready or not. But they took the step to create an EV which people are using. Uh, and that's also what we have heard from on this panel, that test it out, create experiment with the technology, make sure it works, and put it out in the market to get the confidence of people. Second thing which we have heard is collaboration is very important across the value chain. It could be a global collaboration. It could be collaboration with startups, as we heard from our speaker in the morning. But collaboration is a must between academia, research, industry, and of course the companies. The third thing which we have been hearing is about infrastructure. And we heard a very important comment from one of our panelists yesterday, that we must know what to do and how much to do. And which is what also Professor King mentioned, that a cookie cutter approach of we saw this in China, should be implemented in India, is not going to work. We must find something which is appropriate for India. Fourth, of course, on the material side, we must focus on steel. I think the days are not over for steel. Thank you very much, Peter, for that reassuring thing. But we have to do things with steel differently than what we have been doing. Uh, and my last comment is, if I can draw some analogy, 100 years back, if you were rich, you will own a car and ride on horses. 100 years later, which is in early 2000, if you are okay, you will ride in cars, and if you're rich, you will own horses. Next few years from now, I think we are going to ride in EV cars. We will of course keep the horses in the stable, and cars will be as antique and also expensive. And if you're rich, that's what you will do. Professor King, some last words from you as you see this whole subject shifting to the ecosystem.
Yeah, thank you, Peeyush. I think along with the testing platforms that we need the standards to be established and set. And I think in quite a few areas of these emerging technologies, the standards are lagging a little bit behind the pace of technology development. So I think that's important, because the standards that will be agreed ideally internationally will provide confidence for the consumer. And then I think the other key question is the manufacturing reliability of all of this electrification technology. It's still a challenge in some areas, and that needs continued application, particularly when you're looking at the thermal management side for batteries and motors, and power electronics. Thank you.
Okay. So manufacturing reliability and standards to be set. Thank you very much, Professor Ghosh, Professor King, and Peter, for sharing your ideas, your thoughts for this very important discussion, which we wanted to have as a culmination of materiality. This is the first ever platform created by Tata Steel. We look forward to listening to your views. The conversations must go on, seminars must go on, and we hope to meet when we come back at an appropriate time to discuss about materiality and materials. Thank you very much. We'll bring the session to close.